All right, so I'm recording now. I just mentioned before the recording that I'm finishing this chapter or unit today. This won't take me very long. And today we're going to look at two short concepts. One of them is very easy, buffers. And then one of them is kind of a review. And I will admit I'm a little nervous about how the math is going to go today in section 4.5. There's one type of calculation I'm going to show you today where, again, I'm a little nervous about your math capabilities, but we'll see. I'll figure it out once we get there. So as I mentioned on Thursday, it's been a weekend. I know you guys probably can't remember everything, but I mentioned on Thursday what a buffer was. And the key here is that a buffer is a weak acid and its conjugate base. I mentioned some examples of buffers, and I mentioned a classic example of buffers. Again, if you haven't seen this, check out Thursday's class. They've all been uploaded to YouTube. But I mentioned a very popular buffer in your blood. So let me just kind of go back and remind you. A buffer is a chemical that fights changes or resists changes in pH. Okay, in changes in acidity. So, how come when you like eat a lemon or you take a Rennie or you drink drink basic water, why doesn't your body react to that? And it's because your body has a buffer in it. Now, I'm not talking about your stomach. Your stomach is full of hydrochloric acid, very acidic environment. I'm talking about your blood. And your blood inside of it has hydrogen carbonate. So basically, no, not, I guess that's not baking soda, because baking soda is sodium hydrogen carbonate, but it's very close to baking soda, which if any of you guys bake, you make cookies or cupcakes or anything, you use it in the kitchen. Your blood has a very similar chemical, and it's hydrogen carbonate, or what old school chemists would call it bicarbonate. And the way that it works is in your blood, and I know this is review. I know we did this on Thursday. I just want to kind of re-emphasize this. The way that it works is inside your blood, you have bicarbonate or hydrogen carbonate, and it's a weak acid. It's not hydrochloric or sulfuric or nitric, it's weak. And when it reacts, or I guess you could say dissolves in the water in your blood, it also dissociates into hydrogen carbonate, right? I guess that's what I should have been calling this. So in your blood, you have a weak acid and its own conjugate base. So what happens is if an acid or base come in contact with your blood fights back. Meaning if something basic gets introduced into your bloodstream, the weak acid, the bicarbonate buffer, reacts with it and neutralizes it. If something acidic comes in contact with your blood, the weak base, the hydrogen carbonate ion, reacts with it and neutralizes it. So, I mean, it's truly amazing how your body works and how it fights these pH changes. You don't need to memorize this on the bottom. You don't even need to memorize this. What you really need to know is that a buffer is a mixture of a weak acid and its conjugate base, and it resists changes to pH. Okay, so let's move on. Now, this is where I ended on Thursday. I didn't get to this slide. I'm sure all of you are excited to think back a few months ago. I guess for most of you, this would have been maybe October, maybe November of 2020. You guys learned about solubility. I'm doing the labs, not the course, but I'm doing the labs for Chemistry 1120 right now. And we just did the lab on solubility last week. So this would have been towards the end of Chemistry 1120. And I really hope you remember this. You won't need this table too much, don't worry. Actually, I don't think you'll need this table at all in Chemistry 1121, but we're going to go a little deeper into this. All right, before I go deep, I got a chat message here. What do I see? So I have a question in the chat, if someone drinks soap by accident, would it kill the person? I could talk about this a lot because soap is such an amazing chemical. I'll say two things. One, no. Any commercially available soap, like what I mean is a soap you could get at, say, Carrefour or Boots or Khalid or Khalud, sorry, not Khalid, Khalud, or any pharmacy, they're not going to kill you. You might get sick, but you're not going to die. Don't worry. The second thing I'll mention, and I won't go too deep into this, is if any of you guys, or I say guys, I mean students, are going into Chemistry 2420. So this is for my chemical engineering students, not medical science. There's actually an entire section in 2420 about soap and how it works and how it cleans. And I won't get into it today because I don't have time, but so, in summary, soap won't kill you if you drink it, but soap is super cool. It's such an interesting chemical, and it is slightly basic Iman. So I know what you were talking about there. So yeah, you can drink all the soap you want. You might get sick. Don't tell anybody I told you to drink soap, but you won't die. If you drank something like hydrochloric, sulfuric acid, sodium hydroxide in concentrated amounts, yeah, it could actually kill you. Or best case scenario, it did some damage to your insides. And I say best case because at least you didn't die. But I wouldn't drink a strong acid or base. But luckily for us, soap is not strong. And as Maria mentions, soap is typically a weak base. There are soaps out there that have changed their pH, like citrus soaps, lemon soap that are slightly acidic, but typically soap is a weak base. I mean, I'll just mention it here just because I love soap, and this might sound really silly. The science behind why soap works is so simple that it is mind-blowing. So you think of soap, you think of cleaning your hands, it's COVID, it's coronavirus time, and you guys are washing your hands all the time, or I hope you are. What's going on? Like, what happens when you wash your hands? Well, a normal soap, I'm not talking about antibacterial soap with alcohol in it usually. Alcohol kind of ruptures the cells of the virus and makes them unstable. That's not what I'm talking about. I'm talking about classic soap. The way that soap works is it literally makes your hands so slippery that the germs slip away in the water. And I know that sounds like it's too good to be true. It almost sounds fake, but what happens is the soap makes it's a surfactant, which I can talk about in another course, but what happens is the soap makes this slippery layer between the dirt and germs and grease and the oil on your hands, and that when you wash them, all of the germs wash away. And that's typically why when you wash your hands with soap, they tend to feel dry, because the soap naturally washes the oils from your hand. I I could talk about soap for hours, but yeah, I mean, the science behind it is so simple. It's amazing. Again, literally, soap makes your hands so slippery that the germs just wash away in the water. Anyways, I'll stop talking about soap. Aman, yes, I agree. I love talking to you guys about topics not related to the lesson. I think that's why you're my favorite class. Abdul Halim, I'm super happy you're excited for the next chemistry course. I hope I'm your teacher. And then finally, from Abdul Halim, um, this is an important question, which is why I'm reading this carefully. Um, like talking about occupational health and safety or hazards, especially for my medical science students. Yeah, soap is listed as a non-lethal or non-toxic chemical, meaning you could drink it, you could get it in your eyes, but as Abdul Halim says, bleach will definitely kill you. Do not drink bleach. I don't want to get political. I never will get political, but when COVID was happening in America, it's still happening now, but a few months ago, or maybe a year ago, you heard Donald Trump talking about eating aquarium or pool cleaning chemicals, hydroxychloroquine or something. Do not do that. Don't eat bleach or aquarium cleaner, please. No matter what the news says, it will not cure COVID. You will get sick. Anyways, so let me get back to the course on hand here, or the topic on hand. In Chemistry 1120, you guys learned about solubility. And I say we, and I know for some of my students that I've had before, I have to admit, I kind of lied to you. The solubility chart on your or in your data booklet explains how much a solid will dissolve in water. This is at water at typically room temperature, so water at, like, 20, 25 degrees. However, I did lie to you. In real life, all insoluble compounds actually dissolve a little bit. Everything in some way is slightly soluble. Now, I don't mean to make you guys mad. I mean, I didn't really lie to you. Um, I just kind of like hid the truth. So the solubility chart in your data booklet explains if a chemical will easily dissolve at room temperature. In real life, everything dissolves a little bit. And this brings me to a disassociation equation, which you guys do not need to memorize this, don't worry, but I'm talking about dissolving. All dissolving equations are technically equilibrium. So you did this in Chemistry 1120. Again, you don't need to memorize these formulas, don't worry. But if I was going to write an equation to represent how silver chloride, one of my favorite chemicals, by the way, one of my definitely favorite ionic compounds, how it dissolves in water, it would be an equilibrium. The silver chloride solid splits into its ions if it dissolves in water. And this is really important for today. Oops, I showed the answer. So This is a really important concept check, and I'm not putting a star there because it will be on your test this week. I'm putting a star there because we need it for the next step. So I'm going to do question B, and I'm going to ask you guys to do A and C. And again, I know the answers, oops, sorry. I know the answers are there, just pretend they're not. So I'm going to do B. So B, like in chemistry 1120, you would draw an arrow. We're not in 1120 anymore. We are deep into chemistry. We're in chemistry 1121. So I'm going to draw an equilibrium. Now what happens is this chemical splits into its ions. So it splits into barium 2 plus. And I know it's barium 2 plus because I've studied chemistry 1120. I know that barium is in group 2. So you guys might need to, on your computers, bring up the periodic table for this. But I know that barium is 2 plus. And I know that fluorine is F minus. There's only one problem with what I have written right now. I've split barium fluoride into its ions, but I'm not following the rules of chemistry, the rules of physics, the rules of the universe. I haven't followed the law of conservation of atoms or the law of conservation of mass, whatever you want to call it. I have 2 fluorines on the left, right? See over here on the left, there's 2 fluorines, and I only have 1 here. I'm breaking the rules of the universe, and the universe is not happy. So what I do is I put a 2 in front. And that's really important for the next and final step. So guys, it's 4:58. I'm going to give you maybe 2 to 3 minutes. I want you to try A. A is very easy, but I would also like for you to try C. And I just want to give you a hint. SO4 is a polyatomic ion. Don't split SO4 into sulfur and oxygen. It's an ion. Okay, I'm going to shut up. I'll give you 2 to 3 minutes to try this, and I will be back with the answers. And I'll check the chat before I mute myself. Yeah, Iman mentions the table, the solubility table is easy to use, but you won't get this particular question in a test. What you will get is the next question. So we'll get to the test question in a minute. And finally, before I mute myself, Aisha, I can never say that right. Aisha has the answer to A perfectly in the chat. Just don't forget your aqueous. And I'll mute myself and I will be back in 2 minutes. Feel free to put your answers in the chat. I'm recording now. Let's look at the answers to this. There's really one thing I want to address, and it's about my hint at the bottom of the page, but let me pick a different color. I'm feeling green right now, so zinc would turn into zinc 2 plus aqueous, and whoops, sulfur 2 minus aqueous. So some of you guys might be feeling, and I kind of do hope you're feeling this way, stress about remembering this from chemistry 1120. Don't, and again, when I say I hope you're feeling this, it just makes me confident that you remember the material. This is 1121. You do not need to write these equations. This is just setting us up for the next part. So let me do C. and I'll set us up for the next part. Okay, so C breaks down into silver, one of my favorite elements, and sulfate ion. Remember, SO42- is a polyatomic ion. Again, don't stress too much about this. Okay, that is not the complete answer though, because the 2 in front of the silver means I need to put a 2 here. Okay. So what is the point of all this? The point of all this is when you guys see this on your test, wink, 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 you need to know how many ions these chemicals split into. So what I mean is the first chemical splits into 2 ions, right? We have 1 zinc, 1 sulfur. The second chemical splits into 3 ions. Sorry, I ran out of room there. The third chemical also splits into 3 ions. And if you can figure that out, this is the easiest or one of the easiest questions on your test by far. You just have to be able to figure out how many ions these chemicals split into. Okay, so let me show you. Let's put it into practice and we're almost done. Where I'm going with this is we are going to calculate KSP. Huh, another K, right? You're thinking, you already learned KC, you learned KW, you learned KA. Here's another K. Another one. What does KSP mean? KSP represents the equilibrium for the solubility of a chemical. And the SP in particular means the solubility product. So in simple English, KSP represents how soluble is a chemical. And one thing you'll notice if you look at this equation, which I hope you're all looking at, I'm circling it, we do not put solids in our K expressions. Remember that from chapter 3? No liquids, no solids. So the K expression for this equation becomes the concentration of silver ion times the concentration of chloride ion. There's a little typo here. That should, of course, be negative, not positive. Not a big deal. The charges are literally irrelevant. Okay, so KSP. I'm going to do this quick because I really want to get this chapter done today. So how do we write the KSP for these compounds? Well, I know that zinc becomes zinc 2 plus and sulfur 2 minus. Whoops. I know that we've already done these. That's why I'm writing them so quick. I'm not trying to confuse you. We literally just did these. And then this one. Oops, AQ. No, AG. Why am I writing AQ? My brain. I'm getting old. I think my memory is failing me. Okay, so we already did these, and we've already done this in chapter 3. So I'm very quickly going to write the KSP for these. Now, just remember, no solids allowed, right? We cannot include solids into my equation. So the KSP for this one becomes zinc times sulfur, easy. The KSP for this one becomes my barium times my fluorine squared Remember that from chapter 3. And then my bottom one becomes AG times SO42 minus, and I square the AG. Okay, everybody cool? Everybody comfortable with that? Let me check the chat here. Oh, okay, so a couple things. Yeah, so Iman mentions this is another K. Yes, another K. This is like our fourth K. And if you could see my face, I am winking, wink, 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 wink at the next question. Not this question, but I'm winking at the next question. And this will bring us to the end of class. And Abdul Halim mentions he's happy that we have a lot of Ks. And I think I am too. I really think this is why chapters 3 and 4 will be easy or easier on the test, because it's all about K, KKK. It's like such an important number in chemistry. So as Aman asked in this new question, this question won't come in test 2, but will be on the final. And actually, no. Like on test 2, and the final, you do have to write K equations, right? So products over reactants, yes. But this particular question is not on the test or final. Dun, 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 suspense. This question is on the test or final. I'm going to get rid of some of the text here. Okay, so wink, wink, wink. This is, out of everything you've learned today, this question and the next one are definite test questions. And I'm almost done. I'm sorry for going long. I went on a bit of a rant earlier and wasted some time, but we're 2 slides left and we're finished. All right, let me check the chat and I'll look at the answer. And yeah, so as Aman says, why is the hard question always the test question? Well, I don't know what to say about that, but this isn't as hard as it looks. The only thing I'm really nervous about on the next slide is the mathematics. It's not the chemistry, it's the math. So let's look at this question. If we know KSP, so say you know the value, you looked it up in a book. Okay, so I just circled it there. You can calculate the molar solubility of a chemical. And what the molar solubility is the number of moles of solute that will dissolve in 1 liter at room temperature. Typically, I mean, it kind of depends on where you get your K value, blah, blah, blah. We don't need to get into that. But if you know the KSP value, you can calculate the molar solubility. So this is where the math gets hard. So first things first, I have AgCl. I don't need the solid. And I have it turning into Ag and Cl minus. So this is 2 ions. Okay, I have 1 silver, 1 chlorine. And I would write that as KSP equals silver and chlorine. No problem. So this is where I'm nervous. And it's 5:15, so I don't have much time, but I think you guys will get this. If I turn this into a mathematical equation, I will get this. 1.6 times 10 to the negative 10 equals silver. Whoops, sorry. And chlorine. I don't care about aqueous. I'm not going to put aqueous in there. Okay, take a deep breath. Here we go. Are you guys ready? Here comes the math. I'm going to let these equal X. So I'm going to convert this equation into 1.6 times 10 to the negative 6 equals x squared. The chemistry is finished. There is no more chemistry. Now what I'm asking you guys to do is solve this equation. I'm obviously going to show you how to do this, but if any of you are strong in mathematics, you should know how to solve this right away. I have 1.6 times 10 to the negative 10, and don't worry about the scientific notation. This is just a number, and it's equal to x squared. How do I solve for x? Well, the mathematical way to solve for x squared is, and I'm going to read the chat because it's going crazy, is Aman, I think. Yep, Aman and Abdullah have answered it, and Abdullah have answered it. Take the root. This is about as, well, it's almost as crazy as the math gets. There's one more scary, tricky example I'm going to show you in a second. So I'm putting this on my calculator now, and I figure out that x equals 2 sig figs 1.3 times 10 to the negative 5 moles per liter. And what this number means, is that if I took silver chloride and put it into water, for every liter, you would get 1.3 times 10 to the negative 5 moles dissolved. Whew. Okay. Guys, I know I'm almost out of time. I just want to give me Iman, mwah, beautiful chef's. They call it the chef's kiss. Beautiful. You have literally hit on what I want to finish with. I have one more thing to quickly show you. I will finish this on Tuesday, but I want to talk to you about what Aman did, and I will very quickly do this. And I promise you on Tuesday, I will go over this. We can do some more. I think there's more practice here. So we will do this Tuesday. But let me show you this really quick. This is literally how as hard as the math can get in this course. Okay, so no solids. KSP, or just K, I don't care if you put the SP in there, is equal to the concentration of copper 2 plus times what we would call in chemistry the iodate ion. But unfortunately, it is squared. Dun, 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 dramatic music here. Oh man, what do we do if we have this situation? And again, Aman in the chat referenced this beautifully. We would take what's called the cube root. This is literally as hard as the math gets. So I'm going to let these guys equal x, and I'm going to rewrite my KSP as 6.94 times 10 to the minus 8, right? That's that number there, equals x cubed. Okay, now x cubed. For any of you not comfortable with math, you might want to send me an email, chat with me after class, go see your math instructor. But what would you do in math class with this equation? Well, you would do what's called the cube root. It's a button on your calculator. Okay, and I'll review this next class because it is 5:21 and I have to finish, or you guys will get me fired. But this is a button on your calculator, and I can explain this to you on Tuesday. I'm just punching this in on my calculator. Give me 1 second. This is a new calculator for me, so I'm still learning how to use it. Almost done, almost done. Give me 1 second. I'm sorry, guys. New calculator. So I get, when I put this in on my calculator, 4.11 times 10 to the negative 3 mole per liter. And again, what that number means is, if I took copper 2 iodate and put it into water, 4.11 moles, I should say, sorry, 4.11 times 10 to the negative 3 moles would dissolve in a liter of water. I am finished. I do apologize. It's 5:52. Let me read the chat and you guys are free to go. What do we got here? So Aman mentions making the cube root. Abdullah mentions math is better than chemistry. Agreed. I personally love math and I love teaching math. But as Aman mentioned, some of you students are taking calculus, and this is way, way, way easier than calculus for sure. Abdul Halim asks, in the future, will you have a chemistry course that will be 2 hours like math? Maybe. It depends on scheduling, but typically you have 3 hours of chemistry a week and then a 2 or 3 hour lab. Iman mentions that I might be missing something. I don't think I'm missing anything. I think this is a cube root. It's definitely not I don't even know what you would call a quarter root or a 4 root. It's definitely 3 because I have 1 here and 2 here, which equals 3. So it's not, it's definitely a cube root. Don't worry about the charges. The charges on the ions are not relevant. They have nothing to do with balancing. And yeah, Abdul Halim, I couldn't have said it any better myself. Beautiful. Sorry, thank you, Abdul Halim. Yasmin, never. You will never see 4 ions. I'm even going to write this in the chat in all caps. It will only be 2 or 3. And I'll put a wink face there. There you go. So wink, 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 wink on your test on Thursday. You might see one of these questions, wink, 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 and it will be 2 or 3. Just be careful. Yes, don't worry, Aaron and Yasmin. It's easy. I will never give you 4 or 5 or 6. It'll be 2 or 3. Don't worry. Whew. Okay. So guys, it's late. It's 5:24. I know you guys want to leave. Let's finish it here. And if you have any questions in the chat, let me know. Other than that, I will see you on Tuesday. And on Tuesday, I'll finish this section. I'll start chapter 5, and we will have review on Wednesday.